introduction about Malan transform. Malan transform is an important integral transform. It provides a powerful analytical tool for solving problems that involve scaling, asymptotic analysis, and special function. Defined as an integral transform that maps a function f of x defined on a positive real axis to a function of complex variable s. Malan transform is particularly useful in fields such as number theory, signal processing, probability theory, and mathematical physics. Definition of Malan transform. The Malan transform is a function of f of x defined for x greater than 0 is given by m of f of x comma s equal to f of s, that is integral 0 to infinity x power s minus 1 f of x into dx, where s is a complex variable. Basic properties. First, linearity. M into a into f of x plus b into g of x comma s equal to a into f of s plus b into g of s, where a and b are constants. 2. Scaling property. M of f into ax comma s equal to a power minus s f of s, where a greater than 0. 3. Translation in s. M into x power c f of x comma s equal to f of s plus c. 4. Differentiation property. M into x power n f power n into x comma s equal to minus 1 power n f of s plus n into product of k equal to 0 to n minus 1 into s plus k. 5. Convolution property. If f star g of x equal to integral 0 to infinity f of x by t into gt into dt by t, then m of f star g of g comma s equal to f of s g of s. Now let's see the common Malan function table. If the function f of x equal to 1, then the Malan transform f of s equal to 1 by s for real term of s greater than 0. If the function f of x equal to x power a, then the Malan transform f of s equal to 1 by s plus a for real term of s plus a greater than 0. If the function f of x equal to e power minus x, then the Malan transform of f of s equal to gamma of s for real term of s greater than 0. If the function f of x equal to e to the power minus ax, then the Malan transform f of s equal to a power minus s gamma of s for a greater than 0, real term of s greater than 0. If the function f of x is sin x, then the Malan transform f of s equal to gamma of s into sin pi s by 2 for 0 less than real term of s less than 1. If the function f of x equal to cos x, then the Malan transform of f of s equal to gamma of s cos pi s by 2 for 0 less than real term of s less than 1. If the function f of s equal to ln x, then Malan transform of f of s equal to minus 1 by s square for real term of s greater than 0. See the proof of a Malan transform of function f of x equal to 1. The Malan transform of a function f of x is defined as Malan of f of x comma s equal to integral 0 to infinity x power s minus 1 f of x into dx. For f of x equal to 1, then we have Malan of 1 comma s is equal to integral 0 to infinity x power s minus 1 into dx. First, we need to check the convergence. Since the integral is improper, we split it into two parts. For x equal to 0 and x tends to infinity. At x tends to infinity, the integral diverges. So, we alternatively change the integral to 0 less than x less than 1. So, the integral becomes integral 0 to 1 x power s minus 1 into dx. If we evaluate the integral, we get the final answer as 1 by s. Hence, the Malan transform of a constant function f of x equal to 1 is m of 1 comma s equal to 1 by s for real term of s greater than 0. By this manner, we can prove the Malan transform of a function f of x by evaluating the integral first, by checking the convergence, and by the definition of gamma if there is a necessity, or otherwise continue the integral by applying the limits. We can give the final result. Now let's see the examples for Malan transform. Example 1. Find the Malan transform of f of x equal to x square into e power minus 3x where x greater than 0. Solution: given f of x equal to x square e power minus 3x. Applying Malan transform for the f of x, that gives integral 0 to infinity x of s minus 1 x power 2 into e power minus 3x into dx. That gives integral 0 to infinity x of s plus 1 e power minus 3x into dx. Using the gamma function formula, that gives integral 0 to infinity x power n into e power minus ax into dx equal to gamma of n plus 1 by a power n plus 1. Applying this for our example, that gives final result as gamma of s plus 2 by 3 power s plus 2 for real term of s greater than minus 2. Example 2. Find the Malan transform of f of x equal to x cube into e power minus 2x where x greater than 0. Solution: m of x cube into e power minus 2x of s equal to integral 0 to infinity x of s minus 1 into x of x cube into e power minus 2x dx. Combine the powers of x, so we get integral 0 to infinity x of s plus 1 e power minus 2x into dx. Use the gamma function, we get n equal to s plus 2 and a equal to 2. Applying the formula, we get Malan of x cube e power minus 2x of s equal to gamma of s plus 3 by 2 power s plus 3. Example 3. Find the Malan transform of f of x equal to ln x with x greater than 0. Solution: integral 0 to infinity x power s minus 1 into dx equal to 1 by s. Differentiating both sides with respect to s, we get d by ds of 1 by s equal to minus 1 by s square. That gives d by ds into integral 0 to 1 x of s minus 1 into dx equal to integral 0 to 1 x power s minus 1 ln x dx. Now applying the Malan of ln x into s equal to minus 1 by s square for real term of s greater than 0. Now let's see the definition of inverse Malan transform. If f of s is the Malan transform of f of x, then the inverse Malan transform is defined by f of x equal to Malan inverse of f of s equal to 1 by 2 pi I integral c minus I infinity to c plus I infinity x power minus s into f of s into ds, where s equal to sigma plus it is a complex variable and c is a constant. Basic properties for inverse Malan transform. 1. Linearity. For constants a and b, the Malan transform f of s and g of s corresponding to f of x and g of x, we have Malan inverse of a into f of s plus b into g of s equal to a into f of x plus b into g of x. 2. Scaling property. For a greater than 0, we have Malan inverse of a power minus s into f of s of x equal to f of ax. 3. Power shifting property. For any constant a, Malan inverse of f of s plus a into x equal to x power minus a into f of x. 4. Derivative property. For a positive integer n, we have Malan inverse of s power n into f of x equal to minus x into d by dx whole power n into f of x. 5. Convolution property. Let f of s equal to Malan inverse of f of x, g of s equal to Malan inverse of g of x. Then Malan inverse of f of s into g of x equal to f star of g of x equal to integral 0 to infinity f of x by t into gt into dt by t. This is a common inverse Malan table. Previously we have seen common Malan transform table. These two tables plays an important role for solving examples as well as applications of Malan transform. Let's see one example for application of Malan transform to ODE. Consider the differential equation y double dash of t plus 3y dash of t plus 2y of t equal to 0, where t greater than 0 with initial conditions y not equal to 1 and y dash of not equal to 0. Solution: let m of y of t equal to y of s. Multiply the differential equations by t square. We get t square y double dash of t plus 3t square y dash of t plus 2t square y of t equal to 0. Taking Malan transform on both sides, we get m of t square y double dash of t plus 3m t square y dash of t plus 2m t square y of t equal to 0. Is m of t square y double dash of t equal to s of s plus 1 into y of s. M of t square y dash of t equal to minus s plus 1 into y of s plus 1. M of t square y of t equal to s of y of s plus 2. Substitute into the equation, we get s of s plus 1 into y of s minus 3 of s plus 1 into y of s plus 1 plus 2y of s plus 2 equal to 0. This is the difference equation involving shift of the Malan transform y of s. From Malan transform tables, we know Malan of e power minus at equal to gamma of s by a power s. Hence, we assume the Malan transform has the form y of s equal to c of gamma of s by a power s, where c and a are constants. Using the property of gamma function, we get gamma of s plus 1 equal to s of gamma of s. We obtain y of s plus 1 equal to c of gamma of s plus 1 by a power s plus 1. Y of s plus 2 equal to c of gamma of c into gamma of s plus 2 by a power s plus 2. Using the identity gamma of s plus 2 equal to s plus 1 into s gamma of s, we rewrite the expression as y of s plus 1 equal to c into s into gamma of s by a power s plus 1. Y of s plus 2 equal to c into s of s into s plus 1 into gamma of s by a power s plus 2. Substituting y of s plus 1 and y of s plus 2 into, we get s of s plus 1 y of s minus 3 into s plus 1 into y of s plus 1 plus 2y of s plus 2 equal to 0. Now we get s of s plus 1 into c of gamma of s by a power s minus 3s plus 1 into c of s into gamma of s by a power s plus 1 plus 2 into c of s into s plus 1 into gamma of s by a power s plus 2 equal to 0. Factorizing c into gamma of s into s plus 1, we get 1 by as minus 3 into 3 by a power s plus 1 plus 2 by a power s plus 2 equal to 0. Dividing by non-zero factor c of gamma of s into s plus 1, we obtain 1 by as minus 3 by a power s plus 1 plus 2 into a power s plus 2 equal to 0. Multiplying by a power s plus 2, we get a square minus 3a plus 2 equal to 0. We get a minus 1 into a minus 2 equal to 0. That gives a equal to 1 or a equal to 2. Therefore, the general form of y of s is y of s equal to c1 gamma of s plus c2 gamma of s by 2 power s. Using inverse Malan transform formulas, m inverse of gamma of s equal to e power minus t and m inverse of gamma of s by 2 power s equal to e power minus 2t. We obtain the solution y of t equal to c1 e power minus t plus c2 e power minus 2t. Using y not equal to 1, we get c1 plus c2 equal to 1. Using y dash of not equal to 0, minus c1 minus c2 equal to 0. Solving these equations, we get c1 equal to 2 and c2 equal to minus 1. Hence, the solution is y of t equal to 2 e power minus t minus e power minus 2t.